Hey guys, here are notes for 7-1, the distance on the coordinate plane. So we're going to be talking about a new formula that's called the distance formula. So to find the distance between 2 points on a graph, you can use this new distance formula, which is the square root of x minus x squared plus y minus y squared. Now a lot of times though you'll see x2 minus x1 plus y2 minus y1 because you can choose which point you want to be 1 and 2. So I left those out for now. Now, if you do remember on our DCP, we did talk about how to get the distance of this using right triangles as well. I could make a right triangle going like this, and then like this, and then I could use a squared plus b squared equals c squared to get this distance. That's another option. You could always use that Pythagorean theorem. That's the case. But we do have a simple formula that you could just plug in the numbers to get it. So if you're using this formula and you want to find the distance between the point 3, 2, which is over 3 and up 2 right here, and -1, -2, which is this point right here, then you could simply plug those in. And you'll have the 3x minus the other x, so 3 minus the -1 squared, plus y, which is 2, minus the other y, which is -2, 2 minus -2 squared. So you actually end up with 4 squared, which is 16, another 4 squared, which is 16, because with double negatives you make them both pluses. And you get square root of 32, which you could make into a decimal if you wanted to. It'd be about 5.7 or something like that. Or you could break it down into radical 16 times radical 16 times radical 2, which is 4 radical 2. So either way you could do that. So that is the example in the distance formula. Here's another distance formula practice. Here's your x and your y and your second x and your second y. And we could this time start with the back numbers. So instead of starting with the front numbers like I did with this point, we could start with the 2 here, this x minus this x. So 2 minus the -1 squared plus this y, -2 minus this y, which is +2. So here you'll end up with 3 squared, because double negatives again, plus -4 squared. Those are both negative, so add and keep the sign. And you get 9 plus 16, which is radical 25, which really comes out to be 5. Now, where did the distance formula actually come from? And here's a little setup. I just wanted to show it to you because it's interesting information. Here is point A, which we'll call x1, y1. That's our beginning point. We'll call point C x2 because we're moving the x's, but we're still at the same y. We came up 1, 2, 3, 4 units, and here we went up 4 units. So it's the same y, so y1 stays, but different x. We went over farther, so it's x2, y1. This point B is the same as our x2, because we're still just going straight up, but y1's changing, it's going up here to y2. So to get this side of the triangle, you'd have x2 minus x1. You take this point minus this x, and you would get this distance right here. And then this y2 minus this y1 would give you this distance. That's like your little a and your little b, and you're looking for little c. So really we got the distance formula from a squared plus b squared equals c squared, from the Pythagorean theorem. If we use the numbers that I just found, a would be x2 minus x1, so x2 minus x1 squared would be the same as a squared. Y2 minus y1 would be the same as b squared, so y2 minus y1 squared. So we're just going to square root both sides, and there's your distance formula, the one we were just using. So we actually made the distance formula from the Pythagorean theorem. That's why it's always okay to make the right triangle. If you'd rather use the right triangle to find this distance, then that's fine. All right, let's move on. Now, using the distance formula, we can find out if two segments are the same length. So is JK the same as KL? We could find the distance of each, and point J is 3, 3, -5. Point K is -1, 2. Point L is -5, -5. We could use our distance formula. So for JK, 3, we got our 3 minus the -1. That's the x minus the x squared. For the y's, it's going to be -5 minus 2. So this is -5 minus 2. So you're going to end up with 4 squared. Here you're going to end up with -7 squared Here you'll get 16, because 4 squared is 16. Here you'll get 49, because negative 7 times negative 7 is 49. So radical 65 would be your length of JK, which is about 8.1 if we waited a decimal. Now to find KL, we want to see if it's the same radical. We want to still see if it comes out radical 65 from K to L, these 2 points. So we're going to start with our negative 1, x minus the other x minus negative 5. So there's one x, there's your other x. Your y is 2, and your other y was negative 5. So you got double negatives here, you're going to end up with a positive 4 squared. You got double negatives here, you're going to end up with 7 squared. You're going to end up with a 16, and 7 squared is 49, and you can see 16 and 49, same thing, you're going to get radical 65. So the answer to this question right up here is yes, those two are same, and yes, it is an isosceles triangle, because this piece is the same as this piece. Last little distance formula practice here. If you want to write it down, just a little practice. X minus x squared plus y minus y squared. So 2 minus 6, 1 minus negative 2. You get 4 squared, which is 16. You get 3 squared, which is 9. You get radical 25, which comes out as a 5. So last little distance formula practice if you want to try to fill that in if you're using the blank copies. All right, moving on. You can always pause it if you need to. Moving on, we got a midpoint formula. So not only can we find the distance of the whole segment using the distance formula, we could actually find the halfway point of a segment by using what we call the midpoint formula. That would be the x plus x divided by 2. So basically you're trying to find the middle of the x's. So you're adding them together and cutting it in half. You're taking the average of the x's, you're taking the average of the y's. So if I'm using this example right here, I would have 3 plus negative 3 over 2. That's my x plus my x. I'd have 5 plus negative 3 over 2 here, and that would be my y plus y. So it's a 0 and a 1, so your midpoint is the point 0, 1. That's the exact middle between those two endpoints right there. So that's called our midpoint. That means we have two equal pieces. If you ever see the word midpoint, it definitely means that you're going to have two congruent pieces. That's what a midpoint does. It breaks it into two congruent pieces. So just wanted to highlight that, put that in there so that you know that that's always what a midpoint does. It breaks things into two congruent pieces because it finds the exact middle. All right, going to the next page, practice the midpoint a little bit. So find the coordinates of the midpoint. We've got x plus x. So you've got your x plus x, which would be negative 1 plus 3, negative 1 plus 3. Your y plus your y would be 7 plus negative 3. So you'd end up, and you're dividing them both by 2 because you're going to find the average to find the middle, which is the midpoint. So you'd end up with a positive 2 over 2. You'd end up with a positive 4 over 2. So your midpoint is the point 1, 2. It would be the midpoint of these two points right there. Be the point 1, comma 2. Here you'd have 10 plus negative 2 for my x plus my x, 10 plus the negative 2. Here you have 8 plus 5. So this one is a good one to show you because it might not come out even. Oops, sorry. So here you're going to get a positive 8, and there you're going to get a 13. 13 doesn't divide by 2 evenly, but you can always make it a decimal. So it'd be 6.5 or 6.5. So 4 comma 6.5 is the exact middle between those 2 points. If you were to draw a line from this point to this point, you could go right here and you'd be in the exact middle of that line. It would make it break the segment into two equal pieces. Find the coordinates of the other endpoint of a segment with the given endpoint and the midpoint. So this time they give you a point and they give you the middle, and they want you to find the other end. So if this point is in the middle, what would the other endpoint be? So here's what I would suggest. If your first x is 2 and your middle is negative 1, to get from 2 to negative 1, you'd subtracted 3. So from this point to the middle, you subtracted 3. So to get from the middle to the next point, you're going to subtract 3 again. You're going to do the same thing both times. So that way you've got your beginning point and your point in the middle, and you're going to do the exact same thing to get the other endpoint. So if you subtracted 3 here, you're going to subtract 3 here. You're going to end up with your x coordinate being a negative 4. If you started at 6 and you went down to 1, that means you went down 5 spaces to get from 6 down to 1 in the y value. So you got to go down 5 again, you're going to get down to -4. So the other endpoint would be the point -4, -4. That's how that works. So if Q is your endpoint and M is your midpoint, you went from -5 down to -8. That means you went down 3. So from -5 down 3, that gets you to -8. So you got to take the -8 and go down 3 more, and you're going to get down to a -11. Your y value started at 9, and it went all the way down to -2. So you actually went down 11 places to get to -2. You got to go down 11 places again to get to the other endpoint, which would be -13. So my other endpoint would be -11, comma, -13. That would be the other endpoint. That was just a little midpoint practice. Okay, a couple last examples, 2 examples, one on each page. It says a rancher wants to control animals from accessing a pond on his property. He builds a fence around the pond. Find the length of the fence he needs to build the entire fence. So find the length that he needs to go all the way around. So we've got all the points. One unit on this grid is 10 feet. So what we're going to start with is finding the distance from A to B. Okay, because we already know that this top distance is 10. That's a given. And we already know that this down distance is 11. And these weren't supposed to be there, so pretend you didn't see those. This was 10, this was 11, because we just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And this was down 11 units. So we wanted to find from A to B, so I plugged in 4 minus 1 squared and 13 minus 4 squared. That's x minus x squared plus y minus y squared. That would be my distance formula. So I'm going to end up with 3 squared and 9 squared, which is 9 plus 81, which is radical 90, which you could break down 9 times 10, so 3 radical 10 or 9.5. So this is a 9.5. Oh, there it is. Yeah, I bet you didn't see that before. Now we need to find from A to D, the last piece here. So from A to D, you're going to take your 14x minus your 1x, 14 minus 1 squared, and 2 minus 4 squared. 2 minus 4 squared. So you're going to get 13 squared, -2 squared, 169 and 4 is 173. And if you take the square root of 173 on your calculator, you get 13.2. Boom, there it is. So what we need is to find the perimeter, and when you add up all 4 sides, that's 43.7 units all the way around. Now 1 unit is 10 feet. So he needs to multiply that by 10, and he's going to need 437 feet of fence is what's needed. So that's how you would find the perimeter and find out how much fencing he would need to encompass his pond. And one more example. The location of 2 ships are plotted on a coordinate grid below. The ship at point B, which is right here, must be resupplied by the ship at point A. So A's got the supplies, needs to get to B. They're going to meet at a halfway point, and you can see the halfway point. They're going to meet at that halfway point. What are the coordinates of the halfway point, and how far will each of them need to travel to get to that halfway point? So first we would need to find the halfway point. So I'm going to take my 7 plus my -9. Now the 7 is the x, the -9 is the x. So it's x plus x over 2. And the 5 plus the -1 is the 2 y values divided by 2. So you're going to get -2 over 2 and 4 over 2, which is going to give you the halfway point would be the -1, 2. That's my halfway point. Now the next thing they wanted to find out is the distance that they have to travel to get to that halfway point. So we're going to use the distance formula from either point to the midpoint. So you could pick the first point or you could pick the second point. And you just want to get from that point to the midpoint, from that point to the midpoint. Either way it's the same because, remember, it makes 2 equal pieces. So here's my distance formula once again. X minus x squared plus y minus y squared. So I'm going to use the 7.5 because it's positives. I like positives better than negatives. So I'm going to do my x -1 minus my x 7. So -1 minus 7 squared. 2 minus 5 squared. Now that's going to give me a -8 squared, a -3 squared. It's going to give me a 64 and a 9. Square root of 73, which Comes out to be about 8.5 units. So to get from here to here is about 8.5 units. And if you times that by 20, because 1 unit equals 20 miles, so it's going to be 170 miles is what they need. So to get to the midpoint, they're traveling from their point right here, right to the middle right here. And that would be exactly the 170 miles that they would need. It's 8.5 units on the grid there.